In this problem, we're asked to find the pole and zero locations in hertz and the value of K0 for the circuit shown below. And if we look in the text, the transfer function g(v) of s for this circuit is as follows. So let's convert this into standard form. Okay, so if we look, for instance, if we factor out a Cn Rn out of this term, we can rewrite it as S over S plus 1 over Cn Rn. If we factor out a C0 R0 out of this term, we have 1,000 over C0 R0, and then we have this is 1 over 1 plus, this is S plus 1 over C0 R0. So there's the transfer function in standard form. So if we go through and look at the three terms, for instance, here, okay, this is a 0, so we have 1 0. It's at S equals 0, so we have Z1 equals 0 hertz, which is DC. Then if we look at this term, here we have a pole. So we have a pole at S equal minus 1 over Cn Rn, which is minus 1 over 3.18 times 10 to the minus 9th times 10 to the 6th, which is minus 100 pi radians per second. So now if we go to convert that to hertz, we'll divide by 2 pi, so this will give us one at minus 50 hertz. Okay, and if we look over at the next term over there, this gives us a pole. So now we have a pole S equal minus 1 over C0 R0, which is minus 1 79.58 times 10 to the minus 9 times 100. And this is minus 40,000 pi radians per second. So our second pole here in hertz, we take the minus 40,000 pi divided by 2 pi. So that'll give us minus 20,000 hertz. And then we have our last term here. Here's our K0. So now K0 is 1,000 over C0 R0. So that's 1,000 over 79.58 times 10 to the minus 9th times 100, and that's 1.2566 times 10 to the 8th, which is 4 times 10 to the 7th times pi.